Hello students, let us now try to compile and run this program. So far we have implemented only 4 functions there out of these 10 operations that we are supposed to implement for the linked list. We'll check all these 4 functions right now in this tutorial, and later on we'll move ahead and implement the other operations. So here's the menu that I have already explained to you, and we have implemented all these 4 operations from 2 to 5, and rest of the operations are not yet implemented. So in the main function, we have created the list object, as you can see it here, and then we have initialized the list object by calling the init list and passing the address of this list object there, and that will initialize the head and tail with null, and obviously the node count will be initialized to 0. Then we are printing the menu. Okay, that will call the menu function and print that menu to the user into the console. And then we are having this while loop. As long as the quit is 0, it's going to iterate. It's just same as the while loop that we had earlier with the stack and queue operations. Then inside the while loop, we are asking for the choice to the user, and we are getting that choice in the choice variable, and then we are switching that choice. If the choice is 1, obviously it's not yet implemented, so I'm printing that message there. So for all the operations that those are not implemented yet, we are just printing that message, not yet implemented. For case 2, it's insert at head. So if the case 2 is actually chosen by the user, then it is asking to the user to input the data there, and is keeping that data in the data variable. Then it is calling the insert at head operation, right? That's the function that we have written to add a new node as the first node of the linked list. And the first parameter is the address of the list object, and the second one is the data that is supposed to be inserted as the first node. Okay, so this call is going to create a new node and add that node as the first node in the linked list by keeping that data in that node. Now, the case number 3, that's actually the insert at tail operation. I can just copy this and paste it there. So let me copy that, and here it is. Here we'll be calling the insert at tail operation. Parsing parameter will remain same, and this is going to add a new node as the last node of the linked list at the tail, and the data will be kept at that node. So that's insert at tail. So I need to update this printf statement as well. It should be input data to insert at tail, and that should be as last node. So let me give the message there as well as first node. Case 4 is, I think, let me see that it's print list in detail. So we need to call the print list detail, right? That is the function that's going to print the linked list in detail. So this is the function that we must be calling at case 4. Here we go. So from case 4, we will call this operation, print list detail, and we'll be passing the address of the list. Okay. Then in case 5, it is only print list. That's the simple printing. Only the data part will be printed. So again, we need to pass the list address. So we are done. So we are calling all these 4 operations from the switch case. Now let's go ahead and try to compile this. We'll see how that works. Okay, let's now compile the file. GCC. I'm inside the folder where the file is kept. The name of the file is linkedlist.c, and let's go. Oops, we have warnings there, not error, but warnings. If you are having warning, then you can go with the program, you can run the program, no problem with that, but still they can be fatal in future sometimes. So it's a good idea to just eradicate the warnings. The warning is silly actually. I have used this \0 in order to represent null, in order to initialize the null pointers there, but the standard way of doing that is using null in caps. So let me just replace that \0 within single quote with null. So I'll be just selecting this and replacing that every occurrences. So I've replaced every occurrences of \0 with null. You can see that there. Now this editor atom.io is amazing. You see that I have selected one occurrence. I have then used a shortcut key, Control Command Z in my Mac, and I have replaced all the occurrences simultaneously as I go with the typing. This replaces all the occurrences of \0 with null. That's amazing. So you can use Atom for your programming, and you'll have plenty of supporting functions there that will help you to develop the program faster. As you can see that I do not need to search around the file to find out \0 and to replace that. So it's amazing. Okay, so let's get back and try to compile once more. I'll just clear this command shell and gcc link list.c. This time, okay, we do not get any warning there. So I'm running this now. I'm sorry, ./a.out. Okay, you can see the menu there. Option 1 is not implemented. So if I choose option 1, not implemented yet, I will choose option 2. Yes, it is asking for the data that it is supposed to insert as the first node. So I'm giving, say, 200. So 200 has been inserted as the first node there. Then I can go ahead and choose 2 again. Then I'm giving 300. Now you see that this 300 is going to be the first node, content of the first node, as I have chosen that to be inserted as the first node. So 200 now is the content of the second node. Now you can see that just by choosing option 5. So option 5 displays the node contents only. So the 300 is the content of the first node and 200 is that of the second node. Now I can choose option 3 to insert a node at the tail. So I'm giving 500 there. I'll choose 3 again, 600 now, then choosing 5 in order to display the data. So you can see that 500 and 600 has been added there. So 600 is the last node that we have just added last in the linked list. So now let's go ahead and see the details of this printing of this linked list. Okay, I'm choosing 4 for that. So you can see that at first glance you may just find it confusing, but it's really amazing. You see that the content of the head is this. Actually, this is the address of the first node, and you can match that with this. This is actually all about the first node. Within the parentheses, we have the address of the first node, and that is exactly same as the content of the head. You see that? So head contains the address of the first node, and this is the node contents, right? The first is the data, that is 300, and second is the content of the next pointer field, and that is obviously the address of the next node, the second node, and you can match it there. This is the address of the second node, and that is exactly same as this one, and so on. You can find it exactly useful for understanding the linked list. You can see that this is the next field pointer of the second node, and it is the address of the third node. So the second node next field pointer is containing the address of the third node, and the next field of the last node is null. You can see it there. The address of the last node is this one, and that is contained there in the tail pointer. So you can go ahead and run the program in this way and can see how that works and how comprehensive it is to understand the linked list. You just can add one node and can see that how it is inserted at head or tail in this way. That's all for this tutorial. In the next tutorial, we'll be implementing the other operations there, and we'll be adding them in the switch case, and we'll see how they works as well. Thank you very much for joining in.